Moving on to chapter 4.3, comparing and ordering rational numbers. The first thing we're going to do is compare rational numbers, such as fractions and decimals. This is the formal method. We find the least common multiple of the denominators, form the equivalent fractions over this LCD, and then compare. Hardly anybody does this, but I've done what the book told me to do, and I've told you the method. So I'll show you what it looks like. Between 8 and 6, my common denominator is going to be a 24. So I form the equivalent fraction. I have to take 8 times 3 to get 24, so I take 7 times 3 to get 21. You have to, you can put in the little times 3. We're going to compare that with 5 over 6, 24. I'm going to times by 4, so I get a 20. And now 21 compared with 20 is greater than. So 7/8 has to be greater than 5/6. Most people use the shortcut. And you might remember this because I taught it to you last year too. If I'm going to compare 7 over 8 and 5 over 6, we cross multiply. So I'm going to get 6 times 7 is 42, 8 times 5 is 40, compare the 42 and the 40. Okay, we're going to do 7 over 20 compared with 1/2. 2 times 7 is 14, 20 times 1 is 20, we get less than. If we're going to do decimals, the biggest thing you want to watch out for here is the fact that quite often they are going to give you a fraction that ends up with a repeating pattern. So if I get my calculator out, you are going to take the top number divided by the bottom number. And that is going to give us quite a repeat pattern of 4, 2, 8, 5, 7, 1, which we are going to now compare to 0.44. What we do is we compare place value by place value. We have a 4 in the tenths place on the left. We have a 4 in the tenths place on the right. Going back to the left side, I have a 2 in the hundredths, and I compare that to a 4 in the hundredths. Well, 2 is less than 4, so 3/7 is less than 0.44. Now again, I'm going to take my top number, divide by the bottom number of 13, and again, I get quite a repeat pattern. Some of these prime numbers have quite the repeat patterns. Okay, now here again, I have 4 in the tenths place on the left, a 4 on the right. Notice that on the left side, I now have 6 in the hundredths and 5 in the hundredths, so it has to be greater than. Now here's the thing. If they give you a problem like we had in part A, the 7/8 and the 5/6, the 7/20 and the 1/2, if the whole problem is in fractions, you've got to stick with fractions. Use that shortcut method. But if the problem is in a fraction and a decimal, such as this, then I can use decimals and use my calculator. Okay, we are going to order rational numbers, and in particular, we're going to be looking at numbers to the left of 0. Any negative number, you know, is less than the positive numbers, but what happens if we start getting some of these rational numbers? So in this particular diagram, I've showed you, well, what happens if we are comparing -1/8 with -3/8. Now, if you do have a number line, it's really great because farthest to the right, the greater the number. And it's easy to see in our first problem that -1/8 is more to the right than -3/8, so -1/8 is greater than -3/8. But the truth is, you can use that same shortcut method. 2 times negative 3 is negative 6. 4 times negative 1 is negative 4. And negative 4, or negative 6 rather, excuse me, is less than negative 4. You can do the same thing here. 1 times negative 8, or negative 1 times 8 is negative 8. 2 times negative 3 is negative 6. And negative 8 is less than negative 6. Now, here, you have a fraction compared with a whole integer. Well, it's hard for us to imagine, but yep, negative 1/8 is greater than negative 1. Because, again, it's farther to the right on the number line. But we can use that shortcut method, which can be kind of handy if you don't have a number line to use. With decimals, what if I don't have a number line like I'm given here? Well, what I do is I go ahead and I make sure that all my numbers have the same number of place values. So I'll stick a 0 in here after the 0.5. Have I changed the value of 0.5? Absolutely not. Now what I do is I pretend that there is no decimal point at all, or you can go back to saying, well, it's just handier if we do no decimal point at all, and just think that we're comparing negative 50 with negative 45. Well, negative 50 is less than negative 45. Again, I'll put the 0 in here, and I'll compare negative 40 to negative 35. It's got to be less than. I can also see that up here on my number line. Whoa, what do I do with this third one? Well, the truth is I have the same number of place values. I'm comparing negative 5 with negative 20. And the truth is, negative 5 is greater than negative 20. So make sure they have the same number of place values, ignore your decimal point, and compare your integers. Works like a charm. Oh boy, but now I'm ordering. You gotta be careful, because a lot of times on this type of problem, you've got to watch out for those directions, because most often they're going to switch you around. We've always done least to greatest. Now they're going to have you do greatest to least. And if you'll notice, this problem has a combination of decimals and fractions, which means, ta-da, I can use my calculator. Although hopefully for 3/4 you don't have to. You should know that 3/4 is 0.75 because 3/4 is 75 cents. But I need to take 5, divide by 7. And I will get kind of a nasty looking repeat, but since everything else is only 2 place values, that's all I'm going to take, is the first 2 place values. And now I can compare. I want to go from greatest to least. Well, 0.75 has to be greater, because once again, I can pretend there's no decimal point. So 75 is bigger than any other number up there, so therefore 0.75 is, and that gives me 3/4. Sometimes I actually cross them out when I'm done with them. Now I've got 73, 71, and 64. Well, 73 is the next greatest number. And then I'm going to have 5/7 and 0.64. Now notice that in my answer I always give the form of the original problem, not all in decimals. Okay, we look at example 2. The first thing that you should notice right away is there's one negative number up here, and if there is one negative number, that's the smallest one. So that helps. I'm going to take that calculator and get 14/15 to equal 0.93. Notice that this one over here has 3 place values, then I'm going to take this out to 3 place values. And I will take 14 divided by 31, and I'll only take the first 3 place values. Now, if you want to, you can add a 0 here, but you already know it's the smallest one because it's the only negative. Now, again, I can pretend that I don't have a decimal point, I'm comparing 933, 743, and 451. I want the biggest one first. Well, that's going to be my 14 over 15. Then comes my 0.743. Then will come the 14 over 31. And lastly will be my negative rational number of negative 0.65. Okay, you hit pause to try this one, and then I'll go through it. When I converted, I get negative 0.22 and negative 0.18. Now remember, you want the biggest one first. Fraction ones are always going to be bigger than anything that has a negative 1 point something, a negative 4 point something. So I know that these two have to be the smallest. So once I compare, I know that negative 2/11 has to be bigger than negative 2/9, and that negative 3.9 has to be bigger than negative 4.4. And that concludes this particular lesson, so scouting out.